So, 4.1, graphing quadratic functions. Quadratic functions are our ax squared plus bx plus c's. Parabolas are what we graph from those. We have the axis of symmetry. We have the vertex. The parent function is y equals x squared, which we then stretch, reflect, and shift left, right, up, down, translate around. The vertex is the highest or lowest point on the parabola, depending on whether it's a happy face or a sad face. Lowest point, highest point, minimum values for y or maximum values for y at the x-coordinate. The axis of symmetry is that vertical line that goes through it and reflects the left and right side to each other. There are symmetry patterns between points for any parabola, whether it's a happy parabola or a sad parabola, whether it's a sideways parabola or a normal parabola. Parabolas are cool. The minimum maximum thing, A is positive, it's a minimum. If A is negative, it's a maximum. We went over all of this already. So this is the one that we've been focusing on. Parabolas in standard form. We are going to look at vertex form and intercept form. So in standard form, we know to identify the coefficients. We know to find the vertex using negative b over 2a. We know to plug that into the equation to solve for y. Negative 4 plus 8 minus 3. So then we identify the axis of symmetry. X equals the x-coordinate of the vertex. Our A is negative 1, which is less than 0, so we open down. We are a sad parabola. We have a maximum value of 1 for our y's. Since our A is negative 1, the absolute value of that's 1, so we open normally like a regular y equals x squared. We don't have to stretch it. So our pattern is 1, 3, 5. Our vertex is 2, 1. We go over 1, over 1, up 3, over 1, up 5. Takes us off the graph. We reflect those over the axis of symmetry, and we draw in our parabola. Our y-intercept when x equals 0. Oops, I forgot we go down. So let's switch that to a downward facing parabola real quick. Two, 1, 1, 3, 5. We go off, reflect them over the axis of symmetry. When our x is 0, our y is negative 3. Now our picture matches. Or the point 0, negative 3. Our x-intercept, when our y is 0, our x's are 1 and 3. Or the points 1, 0 and 3, 0. Transformations we reflected down. That was the step that I actually forgot the first time. And then we translated right 2 and up 1. Translated right 2 and up 1. Our domain is all real numbers. Negative infinity to infinity. And our range is everything smaller than this y value. So our y's are all less than or equal to 1 from negative infinity to 1 inclusive. Alright, so that's the one we know how to do. We are now going to go and do an example of vertex form and then an example of intercept form, and how that graphing changed a little bit if you don't want to put it back into standard form.